good morning or good afternoon, depending upon what time zone you're currently in. My name is Lourdes Brent. I am with the District Academic Senate of the Los Angeles Community College District. The Professional Development College of the DAS is happy to collaborate with the LACCD Sustainable Environment Institute for a series of seminars on climate-related matters. So with us today from SEI are Beth Abels and George Leddy. I will turn over the mic to them and welcome to you all.
And so faculty do get flex credit, and that's why we asked faculty to access the VRC portal in order to get the link for today. And in that way, faculty will get flex credit for attending the seminar. This is the first one of our summer fall series that we did successfully last year, where we had as many as 5 different topics. This year we have 4, and I think you'll find them all quite compelling and very interesting. And hopefully will also complement or supplement your knowledge, as it might be, on issues like climate and urban heat. And hopefully you'll also be learning a lot of new things that I know that we didn't know until we chose this topic and then started researching and inviting the experts that are here with us today. We sort of do a model. Our model is from the global to the local. That's the way we tend to approach this. At the beginning, we actually have a series of slides that we will share with you, and that will also include some short clips. I think the longest clip we have is from the PBS series called Terra, and it deals with some of the climate and atmospheric phenomena behind the persistent or increasing heat emergencies that are happening primarily in the Northern Hemisphere. But Dr. Finley will elaborate on that quite a bit and even cover some of the controversial science as to what is happening with the jet stream and what can we expect. So all of this is by way of educating ourselves on what we can expect and what we can learn about avoiding the worst extremes, particularly health extremes of exposure to excessive heat. So this was the first topic of the year, appropriate for the month of August, since we're already seeing record heat in Europe in particular with their drought conditions, but also in many parts of the United States. So that last week, for example, New York City had quite a bit of a heat wave, which then this week has tempered quite a bit, which is a nice change. Now let me see. Today's topic will include Dr. Jason Finley and Marta Segura, who's the Chief Heat Officer for the City of Los Angeles. She is the first heat officer in the city of LA, and LA is one of the few, maybe 3 or 4 cities in the United States that now actually have this designated position as a heat officer. So we know the city of Miami has done that as well. Then in September 22nd, we'll have Professor Denise Robb from LA Pierce College, and she will discuss climate politics, an area she does teach political science at Pierce, and she's quite advanced in terms of her understanding of what is going on with climate policy. On October 20th, we'll actually deal with the increasing aridity. So we're maybe dropping the word drought and saying this is such a long-term process that climatologists and physical geographers refer to it as aridity, increasing aridness, and the water issues. We'll have participants to announce about that. And then on November 10th, something we're looking forward to, very important, we're going to actually spend maybe 3 hours on this, and that will be mental health challenges and climate anxiety with Dr. Bhutia from LA Harbor College. We had a chance to see a presentation she made last month at Harbor College and invited her to conduct this particular seminar that touches very closely to faculty because many of our students are confronting mental health challenges that those of us that are older never had to confront when we were their age. So that will be a very important event, and we hope to have actually quite a panel, including Dr. Bhutia. So yes, we know how tough this can be.
We've seen so much extreme weather recently that it's hard to keep up with all the records that have been broken. In fact, in 2021, 10.6% of all weather stations recorded record temperatures. It's easy to blame global warming, but extremes have not only become hotter and drier, they've also gotten wetter, snowier, windier, and colder. So we have to dig a bit deeper to understand why and where these extremes are happening so that we can prepare for what's actually coming our way. Changes we experience in our climate and weather are fascinating and definitely overwhelming at times. But the more we understand about what's happening both today and down the road, the safer we can be.
The jet stream is this meandering, waving, buckling band of west to east moving winds that are situated in the mid latitudes. And they're really important for us as humans in our day-to-day lives because the jet stream seems to dictate much of the weather that we experience. So any change in weather that we have actually is related to how these upper atmosphere winds are changing.
And as we'll see, shifts in the jet stream connect most of the extremes we saw in 2021. The jet stream forms where warm air from the tropics meets cold air from the poles, and it moves weather systems from west to east due to the rotation of the Earth. Without it, we'd see far fewer changes in our daily weather. Exactly how much effect climate change has on the jet stream is hotly debated, but Judah Cohen is a climate researcher whose work focuses on this exact question.
Strength of the jet stream is very much dependent on how large is that temperature difference between the equator and the North Pole. The Arctic is warming 2 to 3 times faster than the rest of the globe. So that means that temperature difference is slackening or weakening. With a weaker temperature difference, also the jet stream is kind of weakening or slackening. The winds are not as fast. Now that I think everybody agrees on. But there is kind of this new idea that really didn't exist 10 years ago, that this weaker jet stream also leads to slower moving weather systems and also a more amplified or greater waves inside the jet stream. So if the waves in the jet stream have much larger north to south extent, there's much more vigorous mixing of air masses. So you bring cold air from let's say the Arctic or in Alaska and Canada, bring them down to Texas and Georgia, right? And so it's very anomalous. If it's cold in Fairbanks, they can handle it. They're used to it. When that same cold air is quickly transported into Dallas, Texas, or Atlanta, Georgia, they're not used to it, and they have causes havoc with our infrastructure and human lives.
This theory may be new, but 2021 made a pretty convincing case. In fact, it's hard to find examples of major weather events from last year that aren't connected to the changes in the jet stream. The Texas deep freeze was caused by the jet stream becoming so wavy that it brought Arctic air from the poles to the southern US. Later, the jet stream was so coiled and slow over the Pacific Northwest that it trapped a high pressure system over that region, allowing hot summer sun to heat stagnant air to new highs. A similar pattern caused flooding in Europe and fires in Siberia. Then Hurricane Ida slowed as it hit the Gulf states, and instead of being pushed offshore by atmospheric winds, it was blocked by a high pressure system and dropped record rain over the eastern US.
And extreme weather is very much strongly connected to changes in the jet stream.
Okay, and that is happening more because of Arctic amplification, correct?
So that, this is a controversial idea. That's an argument that I'm making.
And Judah is not alone. So we'll see in the coming years how this debate plays out. But it's not just wind direction and speed that can change. In fact, the entire system might be migrating, which could mean even more significant and long-lasting changes to our climate at ground level. Matthew Otzman from the University of Arizona's Climate Systems Center recently discovered chilling data that suggests the jet stream is moving north.
If we want to understand how climate change is going to evolve in the future, we need to understand how and why it has changed in the past. So in this case, what my team was able to do was to collect measurements of glacial ice from across Greenland and combine those measurements together in order to dissect properties of the climate that are related to changes in the jet stream.
By doing this, they were able to find changes in the jet stream's position and intensity going back 1,200 years. And they found evidence of big changes.
Going back 1,000 years into the past, we see that changes and where it's positioned across space can be on the order of 10 or more degrees of latitude. So this is a lot of area that the jet stream is covering on these really long time scales. And this, of course, has big impacts on changes in weather that we've seen over the last millennium.
Over the last 100 years, we've been emitting greenhouse gases into the atmosphere, causing the climate to warm. And remember, the jet stream is created where warm southern air meets cold northern air. And if the Earth warms, then the place where those air masses collide might move north because there's less cold air.
And what we can do is actually compare projected changes in the jet stream that we get from models with the range of variability that we see in our reconstruction. This is essentially the range of natural variability. And what we see is that for high greenhouse gas emission scenarios, we might find ourselves in a position where the jet stream becomes effectively distinct from the range of natural variability within the coming decades by as early as 2060 CE. Observations that we have from satellites, as well as estimates of the climate system that we get from models, both agree that the onset of changes in the jet stream's position has already began. It probably began about 20 years ago in the late 20th century. And this is really important because when we start to think about climate extremes, right? So extremes in precipitation or temperature, we care about where the edges of those variations exist.
This is because as the jet stream migrates beyond the limits of its historic range, we're likely to see even greater extremes in our climate than we're used to.
If we continue to emit greenhouse gases, we will see a migration of the jet stream further and further to the north. And as we push the North Atlantic jet stream outside its natural range, we will see consequences in where the temperature extremes as well as precipitation extremes fall for the places where you and I live today.
If this pattern continues to play out, places like California and much of the American Southwest will keep getting hotter and drier as the jet stream delivers less and less moisture from the ocean, while some more temperate regions like the Pacific Northwest will receive even more moisture than they currently do. This means many already dry regions becoming drier and wet regions becoming wetter. And the same pattern would likely hold true across much of Southern and Northern Europe. Our understanding of these changes is still evolving, but Matt and Judah's work underscores the need for preparation.
To introduce Dr. Jason Finley, who I'm going to see if he's already in our participant list here. I have a few more slides to share with you that will help introduce Dr. Finley. He will in fact have interesting observations to make about what we've just seen, because as you'll see, Dr. Finley has actually researched this in great detail. He might even take issue with some of the PBS Terra content that we saw today in terms of their understanding of the very important role of the jet stream. I've seen, for instance, he did share with us the PowerPoint that he'll be using in his part of the presentation. And what I appreciate about it is that he looks very closely at ocean temperatures as well, something that we did not see in what we just saw. Dr. Finley is currently pursuing his second PhD in atmospheric science, so we're very happy to have him here today. One of the things we saw in this recent presentation was the degree to which, of course, burning fossil fuels play such a critical role. And you can see that in terms of how much is the carbon dioxide contribution, and then all the different processes like agriculture and industry, transportation. It's a very useful diagram, which as I will share with you on the website that you can use in a sort of lecture setting. But you can see that the carbon emissions since 1990, which was the baseline for the IPCC Kyoto Accords, has only seen a significant reduction by EU member countries and even Japan, whereas the other OECD countries or advanced industrial countries, US, Australia, and Canada, have in fact increased their carbon emissions since 1990. When we look at temperatures and how they are measured, this little thermometer does supply both the centigrade and Fahrenheit scales, and what is considered a normal body temperature vis-a-vis the boiling point of water. So when we're looking at temperatures in the hundreds, it's where we start really entertaining the possibility of heat stroke occurring to individuals, to people, particularly people that are unhoused, that are outdoors. The trends, of course, we can see are now quite legion. We've seen this ever since James Hansen gave his testimony to the Congress some time ago, warning U.S. policymakers about the reality of climate change and the possible futures involved. And this is an innocent infographic that shows you where the hottest temperatures have been recorded, the large numbers in centigrade, the smaller numbers underneath in Fahrenheit. And maybe at this point, Death Valley wins the prize at 134 degrees Fahrenheit, measured just a few years ago. The heat waves around the world have brought tremendously high temperatures to countries like Pakistan and northern India. And we've seen record temperatures in cities like New Delhi and Karachi. And in terms of the highest ever recorded, actually was 1913 in Death Valley, was 134 degrees Fahrenheit. And I don't see anything quite getting near that except for Tunisia in 1931. So the scenario right now, this is heading into next year, are days with dangerous heat, and that does include portions of Southern California and Arizona, Southern Arizona, not to mention Texas and the Southeast. And then by 2053, what can be expected for days with dangerous heat above 100 degrees Fahrenheit. So the future outlook, the extreme heat will affect easily 48, maybe 50 million people in the United States, right into the immediate 30-day future. I'm going to pin you, Dr. Finley, and I'm going to, you will now have the control of the screen.
Okay, thank you. I wasn't able to catch everything. I logged in a little too late, but I do have a few slides I want to show that will reiterate some of the information that you talked about when it comes to the jet stream, and some other information as well. So, okay. So what I just want to point out is that, yeah, when we talk about the jet stream is actually very important to think about, especially for weather in California. The jet stream and its position, strength, and shape really do have a large impact on the state of California, or the West Coast in general. Also wanted to point out that heat is one of the, when we think of weather fatalities, especially around the world, we might think of hurricanes and tornadoes. Flooding is definitely up there, but heat is still number one. And this has been the case even before we were considering global climate change. So again, I think the talk talked already about, or the PBS clip there already talked about the jet stream. I just wanted to also point out that there are two jet streams that can merge, or the polar jet stream can split, and it carries most of, especially here in California, our winter rain. It can carry the winter rain over into California, or it can travel north and miss us altogether. And that's really important when it comes to not only temperature, but we're also talking about precipitation and moisture in the wintertime. Now, two things about how this is connected to climate. Obviously, one of the biggest parts is that the atmosphere is warming, but now this is still a debate. One of the scenarios that could happen to the jet stream is that it becomes wavier. And what that does is that could actually lead to more extremes. It could lead to a situation where we're getting the jet stream that's zonal and it's focused right over California for an extended period of time. Also, it could create a block, like an omega block, which I'll show you in a second, that could keep us really dry. And in the summertime, it could keep the area really, really warm. So, but one of the things I wanted to talk about too, and again, I think the PBS clip talked about that, is that there is a consensus that the jet stream will migrate more northward than it is right now. I like to use this as a, I'm going to highlight this as an analogy. So I'm not really here to talk about El Nino, but what happens during El Nino is we have, let's see if I can get, I'm going to see if I can get, I'm not going to worry about that. One thing that we get with El Nino is we have warmer water typically over the tropical Eastern Pacific. This over here is where our typical jet stream is during the winter time. And the jet stream is aligned where we have the maximum temperature differential, something related to thermal wind balance, which is, we don't have time to talk a lot about that. However, if we have a larger area of warmth in the tropics, then that area of maximum temperature differential will migrate southward. Okay, so keep that in mind. And this is just a map view of what typically happens during, this is for El Nino, so we have a southern jet, and then we have La Nina, which we have a more northern jet. So if the jet stream is farther north, we will, at least in Southern California, can have drier conditions, which also could mean we have warmer conditions. So we have these two scenarios, and what we are seeing, so here's one interesting thing, is again, remember the jet stream wants to go where we have the maximum temperature differential. I think many of you probably remember our El Nino of 2015, 2016, where we were expecting to get a lot of rain. Well, the ocean temperatures definitely were classified as El Nino down here in the tropics, but we also had warmer waters farther north. So this is not going to have that maximum temperature differential. We have to go farther north to find that. And that's where the jet stream is. And that was the biggest reason why this El Nino of 2015, 2016 did not give Southern California the rain that we're used to. And so here's just another way of looking at it. In the future, again, we have that northern phase, or we have that northern location of the jet stream. Now you might be wondering why if the planet is warming, why would we see this northern shift? Well, there's a couple of reasons. The Hadley cell, which I'm not going to get into too much, is likely to expand. And so that means, and typically the outer boundaries of the Hadley cell with the Ferrel cell and the polar cell, these are all vertical cells in the atmosphere, are expected to move, or at least the Hadley cell is expected to expand. What another possible, so there's just a little difference there between, let's say, Southern California during right now or in the 20th century to something that we might see at the end of this century. The biggest thing that we're noticing is that the Arctic areas are warming almost twice the rate of any other location. And so this is having an impact on temperatures in the Arctic. So overall, the temperatures in the Arctic, especially in the southern fringes of the Arctic Ocean and any landmass, it's warming quite dramatically. So what that does is it confines the coldest temperatures to be a bit farther north than if we weren't dealing with global climate change. And so to find that maximum temperature differential, we're going to have to go farther north. And that's why the jet stream may do that. here's just a nice animation of one of the reasons why we're seeing this increase in temperature much more dramatically in the Arctic. Has a lot to do with there's feedback cycles, and a lot of it has to do with the melting sea ice. Now, again, again, I think PBS talked about this too. There is, again, some debate. One scenario, and you got to remember, a lot of these scenarios, they're based on basic physics and thermodynamics, especially when it comes to the temperature differential. But when it comes to understanding how the actual shape and the ridges and troughs that associate, and sometimes we call them Rossby waves, associated with the jet stream, that's more dynamical, and we use computer models to investigate that. And there's a lot of uncertainty. So, but one thing that has happened already, and this is something that I found from the heat that we saw last year, not just in California, but up into in the Northwest Pacific, is that if we do have a wavier jet stream, even in the summertime, we might get these omega blocks. And this is part of the concept of a heat dome, although usually in the United States, we think of the heat dome as being more over the middle of the US. But this is an example of a heat dome in an area that saw record-breaking temperatures. And when we have a wavier jet stream, we can get some of the patterns to be stuck. So that's why you see the term block here. And so I just wanted to point out here that, again, this is a little bit controversial still, because again, dynamic aspects of the jet stream are based on computer models that aren't perfect. So some suggest that we will have a wavier pattern. Some suggest we may have a stronger but less wavy jet stream. And so it really we just have to continue improving our understanding of how the dynamics work and work on looking at past data and improving our computer models. I also wanted to touch upon, we've been hearing a lot about, this mega flood that might happen. That could also be related to the jet stream, because again, wherever the jet stream is located along the West Coast, that will provide us the rainfall that we might want. Well, we might not want this much rainfall. So this is a situation where we have, and this is a more, when I say zonal, either it's zonal, which is east-west, or it's in terms of atmospheric river, or which can also lead to flooding. We have this jet stream that is perpendicular to the Sierra Nevada mountains. That would produce, with enough moisture, potentially large flooding. And so again, if we're getting a wavy jet stream, and sometimes that pattern is a quote unquote block, then we can just get this abundant amount of rain that could lead to flooding. And I also read a research article recently suggesting that in a warmer world, the snowpack that we rely on here in Southern California, where the snow melts gradually, that's ideal, and fills up the reservoirs. In a warmer world, the snow may melt much more quickly, and so we may not be able to capture the runoff like we can if it would melt more slowly. This is just I believe this is the 1862 recreation of that flood, and this is what some computer models are suggesting in the future. So you can see that there's definitely a high risk of flooding in most of Northern California, and we're also noticing this potential flood in the Central Valley. Now, I don't know if this is getting into someone else's talk, but I do want to point out that, so we're going from global to local. It's not just about, when we think about climate change and greenhouse gases, that's not the full picture. The other aspect that warms the surface is making urban areas from rural areas. So even in small towns, so there's a study done by a former professor of mine that noticed that a town of even just 50,000 people, the core of that city, we call it a city, is almost always warmer than the nearby rural areas. So adding concrete and, adding concrete to an area will not only absorb more heat, but there's less cooling also at night versus, let's say, a comparable area that would be rural. So urban heat island is a term, or urban heat island effect is a term that we use to explain the core or the central parts of a city getting much more heat than the surrounding areas. And this is also true, actually this is especially true at night. One way that some places that I've been to are trying to combat this are, planting more trees, having greener roofs, actually having vegetation on roofs to help sort of curb that urban heat island. So that's all I have for this presentation.
Well,
So I don't know if you want
thank
to-
you, Dr. Finley. We
Yeah,
actually
no
have
problem.
time for Q&A. We've also activated the chat. So if people have questions on this presentation or follow-ups or anything to ask Dr. Finley, feel free to put that in the chat.
Okay.
I have one question actually, and this has to do with my own confusion about things. I should add that my family's origin is from Peru. And so El Nino, the phenomenon, is actually quite well known to people in Peru. And the reason it gets that interesting name is that it has to do with the Christmas holidays, which in Spanish is the Festival del Niño, the Christ child. So they have their summers when we have our winters. So their December months are actually their summer months. The fishers go out to fish anchovy, which is a very, very abundant species right off the coast of Peru. They put their hand in the water. If the water is warm, it's a bad sign. It means that what in marine terms is called cold water upwelling has failed, and that the coastal water is warmer and then doesn't have the nutrients to feed the anchovies. No anchovies, no money, no Christmas. The scientists call it the Southern Oscillation, but I'm wondering, Dr. Finley, I do get confused when the term La Nina gets thrown in. Does that refer to something in the Northern Pacific, or is it an exaggerated version of the normal conditions? In other words, the opposite of El Nino?
So you had it right that second time, the latter. So La Nina is colder than normal waters off the coast of South America that can extend outward into the Central Pacific. So, the cycle of El Nino, which is what you described as correct, and La Nina, they have it's not very stable as far as periodicity. It's between 2 and 7 years. So we sometimes what we'll see is we'll have those warmer waters, El Nino, off the coast, and that'll be maybe a year or less than a year long, and then we can get, sometimes the next year we can get a La Nina, which is sort of a boomerang, or the opposite side of those waters there in the south, in the we say equatorial eastern Pacific.
Yeah. Well, I do read in the papers that Australia gets walloped with major rain. Is that in a La Nina year, Australia gets flooded?
Yeah, so during La Nina, what this is some of the research I'm working on, is what makes an El Nino from one year to another different. So in most La Ninas, what we see is, because we have colder air colder water in the Eastern Pacific that typically leads to more stable, cooler, stable conditions. The trade winds are stronger. And so that pushes warmer water and keeps warmer water to the Western Pacific. And that includes not only in East Asia, but also down in Australia. So during a La Nina, the water the water temperature is warmer, and that can lead to more rainfall in Australia.
I see that Humberto has his hand up and he's on his iPhone. So I'll ask you to unmute Humberto so that we can hear you. Feel free to ask your question.
Sounds good. George, thank you so much for hosting this event. These are always great events for our LACCD students. And Dr. Finley, kudos on the second PhD
Thank you.
goal of yours. That's really unique. Every time I hear of folks having 2 PhDs or even 3, I know someone that has 3. I'm
Really?
just baffled by people that can do that. So kudos to your ambitions. But just curious on how you, do you teach the Pierce College students how to extract some of this global data and how to use GIS and how and analyze the data? Because I think that's where the power comes in, where you can analyze massive amounts of data using tools like GIS and be able to create these different scenarios on what's going on with the world. And if you are, can you just explain where these data sources are coming from?
So I do teach GIS. It's more of a general course because a lot of GIS covers both cultural and the physical geographic aspects. A source of data that I often use for students just to get their hands wet typically come from the National Weather Service. There's also the center, we'll just call it the Climate Center, which houses a lot of historic data. The Pierce College Weather Station also has data that can show different, just even here in Woodland Hills, the increases in temperature over the years. So I hesitate in getting a lot of my students to look at real world data because sometimes it can be a little bit overwhelming at first, especially in my intro courses. But if I teach the GIS course and if I teach my meteorology lab course, yeah, definitely have them look at data and try to make sense of that data. And the data can come from, most of it comes from government sources that are housed here in the United States or through the World Meteorological Organization. I hope that answers your question.
Oh, yeah.
Thank you, Dr. Finley. We do the same thing with survey records. We teach land surveying here at East LA College. And I'm just so blessed to be able to extract data either from the county or from the feds and be able to show the students how easy it is to look at this data that has been recorded by our folks in the past that said these folks in the future are going to need this data online. And so I'm just grateful that we have access to that type of data. So thank you so much.
Yeah, no problem. No problem.
Well, thank you, Dr. Finley. This has been a really extraordinary education for many of us who are maybe not in the STEM fields, but I think it's useful for faculty that might be in social sciences and humanities to get an insight into the science behind understanding the very extreme weather conditions that we're getting with climate change. I don't know if you remember the rather comical Senator Imhoff walked into a Senate meeting with a slush ball in a plastic bag and said, climate change, it's snowing outside, demonstrating a great deal of ignorance. And what we're seeing is the wet places get wetter, the dry places get drier, and then we see these phenomenal extremes. So you've really understand that.
Yeah, the first thing I teach students in my meteorology course is the difference between weather and climate. So if someone's outside bringing a snowball in because of a snowstorm, well, that's weather, and climate is obviously much longer. That's a longer term.
Yes.
Yeah.
I see that there might be. I'm going to check the chat to see if any questions. There's just a very kudos for what we're doing, and I'm glad to hear those. Thank you, folks. And so I now want to switch over to, well, I'm going to introduce some material before we have Marta Segura, who is the Chief Heat Officer for the City of Los Angeles. And she works on environmental justice issues and on neighborhoods and communities that are highly impacted in Los Angeles. So that we will get to momentarily. First, I want to share a couple of things with you that you might find useful. One of those is that the SEI does have a website, very easy to know. It's SEILACCD.net. And today's event is actually in the section called Teaching Resources. Next to that, you'll see the lecture series. So this is starting this summer, fall with August 18th, the heat seminar. I've already posted on it many articles. Some of them are long reports from the Centers for Disease Control and from the Brookings Institution on understanding some of the sort of economic, social, and political issues around maximum heat. And there's also a very important article that is an interview with Marta Segura that came out here in Los Angeles and asks her a lot also about her biography. So I'm glad that that came out in something called Cheerful. And thanks to Google, I found it and I'm posting that here. These are all PDFs for your edification. We also have our current newsletter, which of course advertises today's event, but also thanks to Beth Abels, it includes what is happening with LA County. And then the links, these links will probably be updated as we get, well, one of the things we want to do is make sure that our Zoom meetings are actually closed captioned, and I understand there is a way of doing that. So I apologize for the fact that this one is not, but Beth is going to help me with the next one to make sure that we actually have that. Zoom does a tremendously good job of closed captioning. I've never seen anything better. Thanks to João Benenhorf, who's actually our third person at the SEI. She's created a website on the LA Valley College Library, and that is on climate anxiety. And then the newsletter also features some of the work that the SEI is doing through Beth Abels in terms of creating what is called environmental justice community of practice. She's been working on this for some time now, and we will elaborate more on that as we develop it further. And then we do feature Tree People this particular month because they have a particular useful infographic on how to deal with trees that might be actually getting affected by extreme heat. So thanks to Tree People, we have that to offer. And then we have an article on the recently passed Inflation Reduction Act from the Biden administration, and some of the very good news in there in terms of funding, federal funding for a lot of climate goals. And as controversial as it is, it's unprecedented. We've never seen anything like this in American history. And I think it's very important that we actually are realistic about what's been obtained, and actually credit maybe the White House for having convinced Joe Manchin to sign on. So that is our website, and let's see. Once again, our splash page. So this was the article that I found out about Marta Segura, and it has some of her biography. It's a very interesting piece in Cheerful, and it is posted on the website. So we are now one of maybe 3 cities that has a heat officer, chief heat officer. Marta Segura also has her background as a master's of public health and environmental health sciences from UCLA. And that is something I often encourage my students to consider, is a public health route. We have a mistaken view that people in public health wear lab coats and work with test tubes. Yes, they also work in public policy, they work in community education, they work in statistics, in computer programming. It's a very big field for people with any kind of talent and specialization to get into. And given the challenges that we're facing today, a master's in public health is critically important for a lot of cities to have in their urban staff. So now I'll let Judy Woodruff tell us about urban heat.
Last year set a record for heat-related deaths in the United States, and this year is already shaping up to be worse in terms of high temperatures. Stephanie Sy is back now with this report from Phoenix in Maricopa County, Arizona. which has been at the center of heat-related deaths, and where rising homelessness in recent years is making even more people vulnerable to extreme heat.
Heat is an annual emergency here. The firefighters and paramedics in Phoenix, who we spent a few June afternoons with, frequently respond to heat distress calls, says Captain Chris Marini.
On those days where you mix it in with not drinking, not having proper nutrition, and then also, possibly alcohol or drugs, it's real easy where people, just become, altered, and now they can't take care of themselves and they just start overheating real fast.
In recent years, the homeless have accounted for about half of the total deaths associated with heat in Maricopa County. 2020 was a screaming alarm for officials here. One of the state's driest and hottest summers on record was also its deadliest. Over 520 deaths linked to heat, twice the number of fatalities reported nationally from all other natural disasters combined.
Oops. There, stop. That does give you a bit of a background into the urban heat problem in a different city, the city of Phoenix, which you can imagine is probably even more challenged than the city of Los Angeles. They don't have a marine layer, they don't have a sea breeze, they are out there in the desert. There is a federal website that has been fired up on to deal with heat, and this article is also posted on our website. This is just some of these scary statistics. 702 heat-related deaths occur each year, 67,512 emergency department visits, and 9,235 people are hospitalized due to heat. And you will see that that's actually not evenly distributed in the population.
Changes to our climate mean our communities need to prepare for the health risks of higher temperatures. Extreme heat can lead to heat stroke, heat cramps, heat exhaustion, dehydration, and death. Anyone can be at risk, but some are more vulnerable, including pregnant women, people with heart or lung conditions, young children, older adults, athletes, and outdoor workers. So how do we prepare for extreme heat? Communities can establish cooling centers, plant trees to lower urban temperatures, and educate residents on ways to protect themselves and others, such as drinking plenty of water and checking on older relatives and neighbors.
Well, the city of Paris had a heat wave now some years ago, and the most affected people were actually the elderly living in those famous Parisian garret apartments, which have metal roofs. Temperatures rose well into the hundreds, and they lost about 10,000 people in the city of Paris with that particular heat wave. So this is what we might be able to expect when it comes to what would be increases, temperatures higher than 100 degrees, and you can see that for the maximum temperatures, and this was the 17th of August this year. That's pretty impressive in most of what some people call the lower 48 states, excluding then Alaska and Hawaii. So there is an interesting problem, and this was an op-ed piece that came out in the LA Times on how historic redlining led to extreme heat in the Watts community. I know Marta Segura focuses on this a lot. She looks at the uneven impacts of climate and heat affecting those communities where there's a lack of trees and where there's in fact a lack of proper housing, and in this case, a link between the financial practice of redlining communities of color and devaluing their real estate values as well as their ability to obtain mortgages. And it's in an interesting analysis here. It's an op-ed piece by Bharat Venkat at July 27th of this year. So this shows you a little bit of, this was 1979 when we had a record drought in California, and that was one of our driest years ever. 2003, this is the shape of all the counties that are experiencing significant increases in temperatures, and then what happened in 2019. So not all years are equally hot. The hottest year on record is actually 2019 and 2020, even more so far than this year, but we have plenty of time. As you can see in this particular legend, this is how many of the southeastern states and way up into the Great Lakes, and of course, as far west as New Mexico, experiencing tremendous heat increases. So Los Angeles there, we are in some ways blessed because we are on the coast and we have a marine breeze. But as you can see, and we'll hear from Marta Segura, that does not mean that people don't face extreme heat exposure, particularly the unhoused population that's on the sidewalk downtown. They're out in the open and exposing themselves. This is actually more recent data. And so we'll let Dr. Campbell, he has this is just a very brief explanation as to what heat stroke and heat exhaustion actually are.
Heat stroke is acute hyperthermia. The body temperature goes too high. It's caused by prolonged exposure to hot, often humid, not necessarily, but often humid environments. Humidity makes it worse. Physical exercise in the heat is another main cause. And we normally say heat strokes occurring when the temperature is above 104. That's 40 degrees centigrade, or 105, that's 40.6 degrees centigrade. Now, this is a medical emergency, and the person often doesn't realize that they are in danger because their brain is so hot, it's not working properly. So there can be disorientation, aggression, denial, all these sort of things. These people need organized and managed to bring their temperature down because they probably won't realize. They won't feel good, but they won't know why they're not feeling good. So the disorientation is a real danger factor here. And if this isn't treated, it can quickly damage the brain, the heart, the kidneys, and the muscles. And the damage worsens if treatment is delayed. And of course, this is a potential life-threatening condition.
So then to close this introductory section, there is a short animation.
If you think it's hot now, just wait. Across the globe, a pattern is emerging. Periods of extreme heat are on the rise. During these heat waves, high atmospheric pressure pushes air down, sometimes making it difficult for other weather systems to move in and cool the area. This phenomenon allows sweltering heat to linger for days or even weeks. In the US, these periods are expected to increase across hundreds of cities, raising what's called the heat index. The heat index is a measurement of the combined effects of temperature and humidity, meaning on humid days, a temperature of 91 degrees Fahrenheit may feel more like 103.
It's fine.
It's estimated the average number of days per year with a heat index above 100 degrees Fahrenheit will more than double by mid-century, and the number of days per year above 105 degrees will quadruple. Extreme heat is just one sign of global warming.
So with that introduction, let me close that window, turn on the video. Let me make let me see, Marta Segura, co-host. So I'll go to my participant list.
I don't have any slides there, George, so
Oh,
that's fine.
I just want to make sure that you are co-hosted in case I lose my video.
Okay.
And that does give you some control over that, as well as I will also do the pin so that you will occupy the screen properly. And let's see. Voila. All right, Marta, thank you very much for your participation today. I know that you're actually on the move, and we were very lucky to be able to include you today. As you can see, this is a very, sorry for the pun, hot topic. So by all means, elucidate with us what it is that the city of Los Angeles is doing about this phenomenon.
Great. Thank you, George, and everyone for inviting me to be part of this. And I'm glad that everybody else had visuals and was able to explain the climate science and the urban heat island effect, because the city of Los Angeles, even though you're correct, George, that we have a coastal area nearby, the urban heat island effect and the concrete and the buildings and the lack of vegetation in many parts of the city, specifically, as you mentioned, the vulnerable areas, the frontline communities that have been historically disinvested and redlined in the past, are suffering disproportionately. So it's really not just the homeless. The homeless is definitely a target community that falls within the definition of disadvantaged, and they are a real cause for concern. But we're talking about Wilmington, the San Fernando Valley, Boyle Heights, all the areas that are categorized by the state's Cal Enviro screen as being socioeconomically low income and disadvantaged, living in the highest air pollution burdened areas of LA, also suffering from the greatest unemployment, but also the urban heat island is severe in those areas. And one thing that wasn't mentioned was that when you combine extreme heat and prolonged extreme heat, it stagnates the air pollution and many times the wildfire smoke, so that it has an even larger impact in the areas with this urban heat island effect, right? And if you add to that the increased levels of comorbidities or health disparities like asthma, kidney disease, lung disease, immunocompromised, just about every illness, long-term chronic illness that you can imagine is exacerbated by heat and pollution, right? And so what you have here are preventable hospitalizations and preventable deaths that the city wants to mitigate. That's what the city is trying to prioritize and focus on, is how can our infrastructure investments, how can our policies and leadership and the various departments and cities come together in a way that addresses all of the city, of course, but in particular, these most vulnerable communities, because that is where the city council directed me to work so that we could reduce those hospitalizations and deaths. Because like everyone else, they knew climate change was happening, but they didn't know to the extent that it was affecting public health. Fortunately, I had already been serving as a director of climate emergency mobilization to engage the community around the issues of climate. But when they designated me as chief heat officer, I don't know, maybe 6 to 8 weeks ago, then that gave me a focus to identify how we could prioritize the public health issues and the issue of extreme heat. And another thing that is much more local than the jet stream is that now, instead of just having a summer of heat waves, we have heat waves from June to mid-November. And we have longer heat waves, giving our bodies less time to recover. And if you add stagnated air pollution and or smoke to those long heat waves, people are anticipating that. People are unaware that this climate has changed significantly. And so they go out in the, as pedestrians, catch a bus, go for a run, walk to school, walk to work. And something's very different. Their bodies aren't recovering. And their bodies are dehydrated, and their bodies are experiencing extreme and exacerbated stagnated air pollution and smoke. And all of those multiple factors and more, as you've mentioned, are what are affecting these vulnerable communities. So we may not be the desert, but what the desert has its advantage is it doesn't have the refineries that we have. It doesn't have the other polluting sources that we have historically had. So when their heat stagnates, it doesn't cause the same hospitalization and death rate. So FEMA has categorized LA as the #1 city for these extreme heat hospitalizations and deaths. So what is the city doing about these vulnerable communities? And keep in mind, I've only been in this role a few weeks, but I think the city wants to boldly invest in climate solutions to not just reduce greenhouse gas emissions and reduce pollution, but to make our homes and our infrastructure much more climate adapted. And in order to accomplish that, we are working collaboratively with the Emergency Management Department, the Department of City Planning, the Department of Public Works, and many other departments in the city of LA who are vital in ensuring that we progress in addressing these issues with a network of plants. So for example, we have the local hazard mitigation plan, the climate adaptation plan, the heat action plan. And I think give me 30 more minutes, thanks. So those plans all deal with hazard mitigation. And in the past, for example, the local hazard mitigation plan didn't even address climate hazards. So now we're ensuring that our emergency management department is prioritizing climate hazards, particularly extreme heat, because extreme heat is our primary climate hazard in Los Angeles. So with the leadership of the chief heat officer, as directed by the mayor in the city of LA, we are unsiloing, we are collaborating, and we are ensuring that we're maximizing these resources to address extreme heat and other climate hazards. So what's our strategy? I think our strategy is number one, community engagement and mobilization. We started with Heat Relief for LA Network, a social media campaign, and it's going to be a multi-phase, multi-year campaign where we're asking for partnerships with the local communities, nonprofits, businesses, philanthropy, and other cities and other city departments, so that we can work together in educating and building awareness to prevent some of these preventable deaths and hospitalizations. But we're also using some of our general fund and our climate equity fund to distribute air purifiers and climate adapted air conditioning systems, so that we can begin to pilot how these make a difference in people's lives, particularly in these frontline communities. We also have to really focus on heat resilient infrastructure and modernization. So you mentioned the Inflation Reduction Act and the climate funds that are being distributed through that Inflation Reduction Act. While the city of LA is at the forefront in talking with the Biden administration to ensure that we bring some of those resources to Los Angeles, so Los Angeles can set the model. The other area that you mentioned that we work on is focusing on vulnerable communities. Well, we don't focus on vulnerable communities just because they have the most deaths, just because they have the most hospitalizations, because they have been the sacrifice zones. If over 50% of Los Angeles falls within that Callan virus screen category. So if we don't address these most vulnerable communities in the LA region, we are failing to address climate solutions, and we will fail to meet our climate goals. So it's really out of our own self-interest and survival to include everyone and include their voices, include their recommendations, but include them in the solutions and include them and prioritize them for the investments, right? So that's kind of just like my take on it, because some people think, oh, wow, she's an environmental justice advocate. Of course, she's going to advocate for more resources. Well, no, it's not just because of that. None of us will really survive, or our great grandchildren won't live in the kind of world we live in today. It'll be a lot more earth scorched. It'll be a lot more uninhabitable if we don't act together. And the other thing that I wanted to mention is, for example, a specific policy that I'm working on with other departments is the building decarbonization policy. What is that and why are we working on it? Well, generally in big cities like Los Angeles, over 40% of our greenhouse gas emissions come from buildings. So the city of Los Angeles recognized that some time ago, but also wanted to learn from other cities, their best practices, their mistakes, their course correction. So now the city of LA is taking in all of that data, all of that information, and we're making recommendations both for a new building decarbonization policy, and in the future for a existing building decarbonization policy. What that means for everyone is we want to see in LA where the vast majority of buildings are electrified, which means they don't depend on gas. The gas lines and gas infrastructure will be severely diminished, and future homes in Los Angeles, at least in the city of Los Angeles, won't even be hooked up to gas lines. They will be 100% electrified. And that will, we are hoping that will help reduce our greenhouse gas emissions significantly. But the other impact, if we're able to retrofit older buildings that have the use of gas stoves, but then turn to electrical appliances and energy efficiency retrofits and renewable solar energy panels, you'll improve their indoor public health as well. So we hope to see reduced asthma attacks. We hope to see improved health outcomes. We hope to see the improvement of healthy zones in these vulnerable communities, but also create jobs in these frontline communities and have them be part of the economic revitalization that we hope this green economy and green transition will bring. So it's a lot of work, and I'm fortunate to have some amazing departments, the mayor's leadership and the city council support, and a wonderful staff that is helping our small office, because we're not a department, we're an office, but us helping our small office, which sits in the Board of Public Works and the Department of Public Works, have this kind of impact. And I think the last thing that I'll mention is when we were co-designed as an office by the environmental justice community to have a climate emergency mobilization commission that's representative of the frontline communities of labor, of youth, of the original indigenous tribes of the area. And that commission will then help convey and advise to the city council a roadmap to create equitable climate policy for the city of LA and help to operationalize this Justice 40 initiative that the Biden administration has called all cities and states to follow, so that we can show other cities how to operationalize that, because that just has never been done. And so if LA and California can lead on creating equity metrics and Justice 40 initiative, I think we can help other cities as well. So we want to take on that mantle of being a leader, and with the leadership at your college and helping us mobilize and educate and organize your faculty and your students. I am really thrilled that this partnership is building, because that's part of what I exist for, to build these partnerships and these networks and to expand what we know needs to be done to transform LA.
Well, now I know, Marta Segura, why I'm so happy that we have you on this panel today, because you've complemented our discussion, which was so sciencey before you came on, and you've really brought up the sort of social and economic impacts, the differential impacts on different communities, particularly communities of color. I'm wondering if you can expand on one thing in particular, and that is during these little animations, it was interesting to see included with different vulnerable populations, athletes and young people. Maybe our audience doesn't know that it's not uncommon when there's football practice, even soccer practice on a chrome rubber field in the LAUSD, and it's 104 degrees, that a young person can actually get heat stroke readily. Does the LAUSD work with your office on identifying those days when students should not be out in sports practice?
Well, they have reached out to us, and we've been setting up a meeting in the future. But you see, one thing that I think is important to understand is that LAUSD is its own governance structure. It's its own jurisdiction. And it's even separate from LA County and separate from the city of LA. However, I do know that they've made significant inroads to create climate policy. And what we want to do is include them as part of our, heat relief campaign, and meet with them directly to provide this information. But I think it'd even be better if we brought you and some of your colleagues to this meeting so that you could share the materials that you've shared with us. And I also say what we can do and share what we can do with LAUSD. But it is interesting to create a seamless intergovernmental communication. And I guess right now, my first step is to create that seamless intra-government communication within the city. And then that can begin to expand more so to other jurisdictions, right? But that is one of our goals. And we're already working pretty closely with LA County, and we are working closely with the state of California, but you make a very valid point.
Well, actually, I have two more questions. I'm just checking, make sure that there's no hands up, but they're burning questions. They're actually somewhat controversial to the extent that I, for example, posted on the website this study done at Brookings Institution to show what percentage of urban populations lack air conditioning. And of course, as some of us might know, up in the Northwest, in places like Seattle and Portland, people don't have air conditioning. So when they get these heat waves, they're quite unprepared. However, we know that air conditioning puts a big load on the power grid and would then, in some ways, increase demand on electricity from the power plants that we would probably like to phase out. You mentioned something that caught my attention. You mentioned that there's such a thing as air conditioning or options to, I guess, existing technology. Could you elaborate on that a bit? Because I know that it's a burning question with so many.
Sure. So I've also just been learning about this. So I'm not the expert, but I know that there are advanced heat pump technologies. And the way that they work is that they remove the hot air from the apartment or the home when it's hot. And then they reverse that process and bring in the cold air from the outside when the room is warm. And that reduces the use of gas, that reduces the use of electricity, and doesn't have the impact that a normal air conditioning system is. And what we're going for is thermal comfort. Normally, some people with air conditioning systems even get a bit cold in their rooms, right? That is not the goal. The goal is to prevent hospitalizations and deaths and to ensure that everybody has thermal comfort. And that's around 71, 72. So more and more these heat pumps are being used. And in fact, Jerry Brown was in an interview the other day and he said that his ranch was completely solar powered and completely air conditioned only with this heat pump technology. So it can work in California, not just in the East Coast. And that is something that the city of Los Angeles is looking to promote. Yeah.
That's really interesting because, well, I set the thermostat in my apartment to about 76 to 80, and I find it's actually quite comfortable. It's not, it's not stifling hot, but yes, people set it to 68 degrees and I don't know, they want to live in a refrigerator. Okay, here's another uncomfortable question. We've seen recently, and in fact, I didn't include a little video on the possibility of literally painting streets a white color or lighter color than the asphalt, the black asphalt that, as we saw in the videos, absorbs a lot of heat, radiates it back out in the evening. But we know that cars drive on these. How long would they stay reflective before they're just as schmutzy as everywhere else? And is that the way to go for reducing the urban heat dome? What do you think of street painting?
Yes, the city of Los Angeles is currently conducting a pilot project so that the researchers can take a look at the effectiveness of this cooling technology. And I think the jury's still out as to whether it will have a long-term positive impact on reducing the urban heat island effect, right? We know that the thermal maps that NASA and JPL take show and demonstrate that it indeed reduces the heat on those roads at night. So the assumption is, does that should help the urban heat island, but that correlation has not been proven yet. So I kind of want to agree with you there that it's still something that's out for the researchers to tell us whether it actually works. But I think what I want to say is that Los Angeles has always been a leader in attempting new technologies so that we can lead the way and demonstrate what works. So this may or may not work, but we're trying it on a small scale to see if it is a climate solution that we can move forward with, right?
Well, associated with that question, I live in the San Fernando Valley. I live in Van Nuys, and of course, it goes into triple digits. But our main problem isn't so much the boulevards as it is the very large areas dedicated to surface parking. Every shopping center has big areas, and it's usually asphalt, so it is black. And then, of course, all the cars reflect a lot of heat back out. I've heard I watch too much YouTube, but there's some urban planners that say this is the worst thing about modern cities is what they call streets, which are these streets that are roads and they're full of, big billboards and lots of parking. If you see it on Google Maps, it's astounding how much of the San Fernando Valley is these huge difference for cars. And does LA contemplate anything different with regard to car parking?
Yeah, well, when I served on the planning commission was very in favor of reducing the number of parking lots for the buildings that were being approved, because the goal was to, encourage public transportation, right? And the goal of creating transit-oriented development is to encourage public transportation. I think that that's still being accomplished, right? And I think we need to do more of that for the San Fernando Valley. I think the San Fernando Valley is still working on its public transportation issue through the city of Los Angeles. And the more public transportation we have, the less we'll need those huge parking lots. And in fact, I would say that it would be great for those parking lots to create bioswales, to create opportunity to plant trees, benches. So those are short-term solutions. And then maybe in the future, we can convert them to open space, right? So I think the city of Los Angeles is thinking of those things, but it's intentionally reducing the parking lot sizes of any future development so that we don't have that double-edged sword. Yeah.
Right. Well, I know that Jason Finley actually has a conflict at 2:30. He's excuse me, I'm looking at the clock here at 12:30. So he will be logging off. But it was really wonderful to have Dr. Finley on today, as well as Marta Segura. And I have yet another. I'm looking to see if people have questions in the chat. But I have a question that deals with your other work. Well, maybe it's not your other work, but I've noticed in your biography that you work a lot around climate issues and what we call EJ, environmental justice issues in the city, something that you actually were doing even before you became the chief heat officer. Can you elucidate for those of us here why that is so important in the city of Los Angeles? You did mention that there were these, what do they call, environmental screens that showed, was it 40%, over 40% of Los Angeles, or 50% is in areas that could be called, in that sense, vulnerable, or and you also mentioned air pollution. And I think that's one of my takeaways from your talk today was that, yes, an urban area is qualitatively different from a hot desert because of all of the fumes that we're breathing. And so the whole idea of phasing out gas makes a lot more sense than people might think, because gas is methane, and that is a super duper heat trapping gas compared to carbon dioxide. I'm seeing, let me see if there are questions. One of the few things you could see cities vital happen around yada yada. Oh, there's.
You wanted me to talk about the relationship with EJ communities and why that's so vital? Yeah. Okay, great. So CMO, like I said, was co-designed by the environmental and social justice communities. And so part of our blueprint, and maybe Rebecca can share that too. Rebecca's from my team and she's participant today. Part of that blueprint is to engage them from the very beginning in the design of what we call our Climate Equity LA series. It's an annual series that we host, very much like this, but for the broader Los Angeles audience, but we particularly target for our outreach these frontline communities. And these frontline community leaders are part of the design of the topics that we cover. And those topics that we cover lead to the policy areas that they will advocate for. So this year we had building decarbonization, community-driven climate resilience, and we also had Justice 40 and climate equity metrics. And so we had focus groups, we had surveys, we took notes of all the breakout sessions we had during the Climate Equity LA series. Why? Because we feel that city governments and government as a whole has created false solutions without the wisdom of its community members. And these false solutions probably would have been prevented if they had involved the wisdom of these community leaders. And so when, especially when we're talking about the use of general funds that will impact all of Los Angeles, and in particular, communities that are in the front lines, we want to make sure that everyone's involved in the policy making. And because the city of Los Angeles, the city council and the mayor are committed to equitable climate policy development, it's critical for us to, walk the talk and include that wisdom in the design of our policies. So that's the goal, right? To include them, to avoid maladaptations, to avoid unintended consequences, and then to maximize the use of those resources. So we're not creating a solution for Paul, but a problem for Mary, and that's what's been done in the past with various climate policies and investments. Too many to name here, but I'm sure that you all could name some. And in fact, if you'd like to list them on the chat, I'm sure quite a few people could list where we've invested in climate policies, but it's failed or it's disproportionately impacted these frontline communities. So that's why one of the many reasons we feel it's critical to involve and engage and mobilize all of LA, but especially the disinvested and those that had been excluded in the past.
Well, that's a very welcome comment, because all too often, what we see when we look at mainstream sources, that giving a tax break to buy a Tesla is somehow going to fix the climate problem, or incentives for people to buy electric cars, and a lot of that I think is what I'll call lifestyle preservation, as opposed to a conflict with the climate problem and its
Right.
cause. Do you think that we need to do something federally or even locally in terms of declaring a climate emergency? Would that make a difference in terms of priorities and funding? And would it make your job, well, maybe more challenging, but easier?
Well, I mean, the city of Los Angeles has declared a climate emergency, and that's why they developed the Climate Emergency Mobilization Office. I don't know if the county has done that. I don't know if the entire region has done that, but the city of LA certainly was one of the first in the nation, if not the first in the nation, to do so. And I do think it makes my job easier in the sense that it helps with the buy-in, because I know the council's behind me, I know the mayor's behind me. The community was already, supportive. So the community was just waiting for the city to take a step to create this opportunity to co-advise, co-counsel, co-design equitable climate policy.
Well, that's good to know, because actually it's been suggested that the LA Community College District pressure our Board of Trustees to declare a climate emergency, and we have made some headway recently at West LA College. There's now a funded climate center, and I think a lot of their goal is education to the community, outreach to K through 12. They just got a $5 million grant from the state of California, and I think $1.5 million from Senator Alex Padilla, and that will start the climate center at West LA College, which hopefully will be able to imitate some of their curriculum ideas in our 9-campus system, which is more than 200,000 students and 5,000 faculty. So that's why I'm glad that this is being recorded, because we then share that and we post it, and then it might very well be used in a classroom setting or even in something like that. I want to make sure that everybody's had an opportunity to ask questions. I don't mean to monopolize it, just I'm full of questions when people present things that are very compelling and interesting, and it triggers. Beth Abels has her hand raised. Go ahead, Beth.
Hi, thank you so much for being here and talking to us about what LA is on. It's very, I'm kind of torn between excited and terrified at the same time, proud and also like really sad. But so thank you for taking this on. It sounds like it's a very complex and big deal here. But my question is, I think for us who are faculty and students, is more about the major, if there are major strategies that you think we could be helpful with. Are there things that you're seeing as important to accomplish that we might play a role in? So legislature, tree planting, whatever that is that might be more supportive of the city and its initiatives.
Great. Well, no, I'll definitely give that some more thought, because the city definitely wants to set an example for the rest of the cities in LA County. And then some of those cities are also setting examples, right? So we want to make sure to make those examples that are best practices much more visible. But like you said, also then work together as we're pushing for legislation to help resolve this climate challenge. So I welcome your collaboration and your participation. I just don't have a very specific, example at the moment, but I will definitely give it a lot of thought. Thank you, Beth.
Thank you.
I've got one more little question, because I saw this in one of the articles, and it was about the federal level. But when I lived in the city of West Hollywood, on very, very hot days, they would announce a cooling center. Does Los Angeles have a sort of a map of how would a person find out where a cooling center is located and how they could actually send a loved one, somebody who needs the air conditioning that they might not have at home?
Great. That's a great question. We just expanded our cooling center network, so to speak, and we share a map with LA County, because so many areas of the city are adjacent to LA County, and we want to be as seamless as possible. So this year we included 73 additional libraries. They were always available for cooling, but they weren't on the map. So now they're on the map. And I think if there's a few ways. You can Google Los Angeles cooling centers, and it will give you that LA regional map for both county and city. And then in addition to that, the City Emergency Management Department website has a list of the cooling centers that Rebecca just listed. The other thing that I recommend for everyday people is to call 311 and say, where's my nearest cooling center? But just know that your local libraries, as long as their hours of operation are open, then you can go into any local library for respite and refuge for cooling. Some community centers are also designated cooling centers during these heat waves. And fortunately, you don't have to wait till the National Weather Service or Los Angeles declares a heat wave to walk into the library. You could just walk into the library, even if it's in the 80s, if it's in the 90s, and you don't have cooling at home, right? So I definitely would want to guide you to those maps with, Googling Los Angeles cooling centers, and to call 311. And for the county, you call 211. And that's how I would go about it. But we have it on various websites. And for example, our website will launch mid-September. So we'll have a copy of it on the Climate Emergency Mobilization Office's website. The Emergency Management Department also has it. But I tend to just Google it, even though I know where to find it, because it's easier for me to find that way.
Well, I hope people have been watching the chat, because Rebecca Guerra has been actually posting, and all these mentions that we're making, she's posting the links, starting with the environmental screening and all the way through cooling centers and maps. Yeah. So thank you, Rebecca, for sharing that. So I've been clicking on them and loading my tabs as I can.
I will say one thing about the cooling centers, though. There was like this move to build more cooling centers, and there's still investment funding available for that. But what we've discovered, and the Asia Pacific Environmental Network wrote a report on this, and maybe Rebecca can post that too. I think it's called Something Before Disaster. Be that as it may, if you're going to create a cooling center and build one, it's probably not as good an idea as retrofitting an existing nonprofit or an existing community center that's already well used, because people are going to go to the resources they already know of. If you're building something entirely new and you haven't done the outreach, you haven't done the programming, people don't know it as a community resource, they're probably not going to go, and it's probably going to sit empty. And for example, the city and the county sometimes have opened up more cooling centers than are used. And why? And why that hasn't been as successful as we'd hoped is because people just don't know that they're there for their use. So part of our outreach and mobilization is to let people know that they're there for their use. And we're also trying to create pop-up cooling facilities for the homeless. And currently there are some cool spots near Skid Row, for example, that they can go to with hydration stations and shade structure, but certainly not enough. So we're going to need more investments into creating these pop-up cooling facilities for the homeless and for pedestrians that are always out there. And Rebecca just posted that information as well. Thanks, Rebecca.
She's very, very quick.
She's quick.
We actually had more time today than obviously that we needed, because we had a full 2 hours. Our usual time is 90 minutes. But I really appreciate your contribution today, and Dr. Finley. And I think a lot of us have learned a lot about urban heat that we didn't know before, but particularly the resources you've shared in terms of how we can find out what to do, what is the future for things like cooling, what are some of the controversial issues like the heat reflectivity of the city. And this has been really very, very useful to all of us in the LACCD. And as you know, we will share this on that website that I showed at the beginning. That's seilaccd.net. And that will get you to teaching resources. And today's event is there with all of the accompanying articles, the recording, and hopefully people will be able to make use of it long after our meeting is over today. I have no further questions. I'm looking to see if there's anybody has their hand up from Lords Brent. Thank you, Maria Segura and Jason Finley. That's from Lords Brent, our host at the Professional Development College, for which faculty get flex time for attending this series. It was Lords Brent idea that we do this last year, and based on the success we had last year, we're doing it again this year. So thank you very much, Marta Segura and Rebecca Guerra. Your contribution today has been very, very useful for everybody here, and it's been fantastically informative. So I'm going to stop the recording now, not seeing any burning questions there. And let me see, and then I will send you the link by email. But once again, thank you for extending your time where you are in order to speak with us today.
Of course, thank you so much for the invitation, and I look forward to further collaboration.